Graphing using slope-intercept form. Our learning targets today are that we will be able to graph a line by hand given key features of the graph, to state a solution of a given graph, and to state the domain and range for a function. So linear functions are functions that have a constant rate of change or slope, and all but a vertical line, this is when we have just x is equal to a constant, have a y-intercept. Slope is the relationship of rise over run. Okay, we use the variable m to represent that. It is also change in y, or delta y, over change in x. So it's a ratio of the rise to run. So how steep a line is, or what the grade of a line is. Slope-intercept form includes both the slope, which are directions to get from one point to the next, and how steep from one point to the next, and a place to start, the y-intercept. So m is the slope of the line, and b is the y-intercept of the line. So we want to remember that m is the coefficient of x. Okay, so it's always going to be the number that comes before the x. And just a reminder, when we learned about slope, lines that have a positive slope, as we read the line from left to right, the slope is increasing. That's a positive slope. And if, when we read the line from left to right, this line is falling, that means that it has a negative slope. The slope is the coefficient of the variable. Do not include x when you're giving the slope. Okay, slope is just a number. And the number could be a whole number, it could be a fraction, it could be positive, it could be negative, but it is just the number, not the x. So please do not include the x when you're giving the slope. That will be incorrect. So it's just a ratio of how steep the line is. So state the slope and y-intercept of the function y equals 3x plus 4. So using our slope, this one is already written in slope-intercept form for us. So we look at the corresponding coefficient here. The coefficient of x is your slope. So here our slope is 3. Or if you wanted to write it as a fraction, you could write it as 3 over 1. That would give you your rise over run. And your y-intercept is 4. So that this means that the line will cross the y-axis at positive 4, and it'll have a positive slope of 3. So it'll go up 3, right 1, up 3, right 1. Okay, or it could go down 3, left 1. We'll practice graphing those in a moment. So when we look at the second line, this is not in slope-intercept form. So we need to pull on our last lesson from Unit 2, writing y as a function of x, because we want to get y, we want to isolate the variable y, so that makes it convenient for us to graph the equation. So we have 6x minus 2y equals 4. And we want to isolate the variable y so that we can conveniently graph our equation. We want it in slope-intercept form. So we want to isolate the variable y. We start off with subtracting 6x from each side. 6x minus 6x is 0. This leaves us with negative 2y equals negative 6x plus 4. And then we see that y is being multiplied by negative 2. So we divide everything by negative 2. This gives us y equals 3x minus 2. So now our equation is in slope-intercept form. We can see that our our slope, which is the coefficient of x, is 3, and our y-intercept is negative 2. Okay, so that's those are the key features of a line in slope-intercept form: the slope and the y-intercept. That's why it's called slope-intercept form. So let's talk about domain. Domain is the set of all the inputs. Also known as x values of a function. And range is the set of all of the outputs, or the y values of the function. Zeros are where the line crosses the x-axis. I'll say function because it's true for lines, but it's also true for nonlinear functions. Let me get the camera on the paper here. Okay, so zeros are where the function intersects the x-axis. Okay, so if you had a coordinate plane and a line going through the coordinate plane, the point at which the line crosses the x-axis is called a zero. Okay, and that it's called a zero because your y value of your coordinate is always going to be 0. So let's say this is 2, 0. This point is 2, 0. So our 0 would be 2, okay, because our line goes through the x-axis at 2, okay, it means our y value is 0. If we wrote it as an ordered pair, it would be written as 2, 0. All right, let's go on to the next page. Okay, adjust the camera here. So graphing linear functions using slope-intercept form. So let's talk about how do we graph functions once they're in slope-intercept form. So first of all, we need a starting point. Okay, so we will solve to get y by itself. If it's not already isolated, we want the y variable by itself. That's going to always help us with graphing. Isolate the y variable. Okay, and then we want to plot the y-intercept on the graph. That'll be your starting point. And then in slope-intercept form, that's called b. So plot the y-intercept on the graph. Okay, using slope, plot additional points. Okay, and then graph the line. So let's go ahead and walk through that together. If we're looking at example A, we have y equals 2x plus 1. So first of all, this is already in slope-intercept form for us. Remember, slope-intercept form is y equals mx plus b. M is the slope and b is the y-intercept. So our slope m is 2 and our y-intercept is 1. So I'm going to start off, I need a starting point. So this is just a rise over 1. This is where our line is going to cross the y-axis. So I know that it's going to cross through the y-axis at 1. So I'm going to go right here to positive 1, and I'm going to plot my point. And then I know that my slope is 2. So we already had our y variable was already isolated. We plotted the y-intercept. Now we're going to use the slope to plot additional points and then graph the line by connecting those points. So our y-intercept was at positive 1. Our slope is 2. So if you think of that as a fraction, it's 2 over 1. That's our rise over 1. And it's a positive number, so as we move from left to right, it will be increasing. So from this point, I'll go up to right 1, up to right 1. I can also go down to left 1. As long as I'm staying in that line, I can go in either direction. And then I am going to use any straight edge to graph the line. And remember, you want to extend your graph extend your line to the end of the graph, and we want to put arrows, so that is an indication that the line goes on infinitely in both directions. So what are the zeros? In other words, where does our line cross the x-axis? For right now, we're just going to estimate that. We're not going to calculate that out. So our zero, this would go through the line, the x-axis at about negative 1/2. So then we're asked to state a solution and a non-solution of the line. So for a solution, I'm just going to use the y-intercept. So 0, 1. Okay, so that's my y-intercept. I know that's a solution of the graph. And then a non-solution is any point that's not on the line. So for your solution, you could have chosen, first of all, we want to recognize that there are infinitely many solutions. So a line is made up of infinitely many points all strung together. And so we could have chosen, I just chose the y-intercept because it's convenient, it's right there. I could have chosen any of the points on this line. So I could have chosen 1, 3, I could have chosen 2, 5. I could have chosen a point that's not a whole number. I could have chosen a point that's a decimal. So there are infinitely many choices that I could choose for the points, remember, because the lines go on infinitely in both directions. So there are infinitely many correct answers for this solution. Likewise, there are infinitely many correct answers for a non-solution. I'm just going to choose the origin 0, 0. This line does not go through 0, 0, so 0, 0 is a non-solution. All right, example 2 is also in slope-intercept form for us, which is great. So this has a slope of negative 2. This has a y-intercept of positive 3. Oh, I'm going to go back to this example A, domain and range. So domain, remember, is the set of all the inputs. These are all of our x values. This tells us how far left and how far right our line goes. So if I were to look at my x values, does this line exist at x equals 0? Yes. There's the point. Does it exist at x equals 1? Yes. X equals 2? Yes. X equals 3. And it will continue to exist everywhere. So, and as you move to the right, your line's moving up, so there will be infinitely many points there. And then the same thing is true as we move to our negative x value. So does our function exist at negative 1? Yes, there's a point. Negative 2? Yes, there's a point. Negative 3? Yes. Negative 4? Yes. And it'll continue to have values there. So this line has a domain of negative infinity, so it goes left forever, to positive infinity because it goes right forever. So this is the infinity symbol. It's kind of like a sideways 8. So we want to write our domain as negative infinity to positive infinity. And when we list infinity, so we're going to use interval notation all through our high school math classes. So infinity in interval notation is always noted with a parentheses. Okay, so negative infinity to positive infinity. Range. Remember, range is all of our y values, or the set of outputs. How high up does the function go? How low down does the function go? And the same thing is true, just like it goes left forever and right forever, it continues to go up forever in the positive direction. So this is positive direction, is positive infinity, and then it goes down forever. And as we move left, our function goes down, down, down. So our y values, it goes down to negative infinity. So our range is also negative infinity to positive infinity. When we list domain and range, we always list them from smallest to largest. So there'll always be your smaller number, which obviously negative infinity is smaller than positive infinity. Your smaller numbers will always be listed first, and then your second number, your larger number, will always be listed second. So our domain and range are both negative infinity to infinity. That won't always be true, but if the line is slanted, it will. Okay. Number 2. Our slope is -2, our y-intercept is 3. So I know the line crosses the y-axis at +3, so that's going to be my starting point, and I know there's a slope of -2, so m equals -2/1. So this slope is going to fall as we read it from left to right, so it has a negative slope. So down to right 1, from my starting point, which is the y-intercept, down to right 1, and then I can also go up to left 1, because as long as I have a negative slope of my line, I can go in either direction. Extend your line to the end of each side. Domain. So remember, domain is how far left, how far right. Well, our line goes left forever. It goes right forever. So our domain is -infinity to infinity. And remember, if that's confusing, think of your x values. Can I keep going left forever with x values? Will my line exist forever as I move left? Yes, it will. It just gets higher and higher. And then as I move right, so remember, domain is all those x values, left and right. As I move right, does my line continue to exist? Yes, it continues. It can be, it can be 1, it can be 10, it can be 100, it can be 1,000, it can be a million, it can be 100 million. Okay, so it does continue infinitely in the right direction. So -infinity to infinity for the domain. Remember, range is the set of outputs, our y values. How high up, how low down does the function go? And it does go up forever, it does go down forever. So our range is -infinity to +infinity. And again, using interval notation, we use parentheses. Okay, zeros, where does this cross the x-axis? So this crosses the x-axis approximately, looks like 1.5. Okay, so x equals 1.5, and we'll talk about calculating those algebraically very soon, but for now we're just estimating. And then state a solution. I'm just going to, I don't want to use the y-intercept again, but if I did, it would be 0, 3. I'll choose another point. I'll choose 2, -1. And then a non-solution, I'm just going to pick the origin again, because that's obviously not a solution. Okay, I could choose 10, 10, I could choose -10, -10, I could choose -10, +10, any of those points, as long as it's not on the line. Graphing linear equations, let's see, next we have y equals 3/4 x minus 2. So our slope is 3/4, m equals 3/4. Our y-intercept is -2. Okay, so then I can go ahead and graph that line. I want to start at my y-intercept. Remember, my line crosses the y-axis at -2. So there's my y-axis. There's -2. My slope is positive because 3/4 is a positive number. And so my rise is 3, my run is 4. So I'll go up 3, right 4, up 3, right 4. So that's the ratio. I can also go down 3, left 4. Lost count there. Okay. Okay, domain and range. This goes left forever, it goes right forever. So as I move left, this line will continue to exist. As I move right, the line will continue to exist. So remember, domain is all the x values, so -infinity to +infinity. Range is all of our y values, so also it goes down forever. So my y values, any y value will work for this line. Any x value will have a point on this line. So -infinity to +infinity. Zeros, where does the line cross the x-axis? Again, we have an estimation. I would say 2.5. So x equals 2.5. State a solution. I'll just choose 4, 1. You could also choose 0, -2, any point on the line. And then a non-solution, any point that's not on the line. So I'm just going to stick with the origin, 0, 0. Okay, letter D is a little bit more difficult because now they're not giving us the line in slope-intercept form. This is in a form we'll learn a little bit more about later. It's called standard form. So again, we want to get that y by itself. So we want to isolate the variable y. So I will subtract 8x from each side. This gives me -4y equals -8x plus 12. And then I'll divide each term by -4. This will give me y equals, a negative divided by a negative is a positive. 8 divided by 4 is 2, so y equals 2x minus 3. Okay, so our slope is +2. Our y-intercept is -3. M equals 2, b equals -3. So remember, slope-intercept form, y equals mx plus b. M is our slope, b is our y-intercept. So I can go ahead and plot the y-intercept. So this line will go through the y-axis at -3. And it has a slope of +2. So I go up 2, right 1. Okay, or you could do it proportionally, so you can go, up 6 as long as you go over 3. Keep that 2-to-1 ratio. And then graph your line. Okay, domain. So that's, again, all of our x values, our inputs. It goes left forever, it goes right forever. So -infinity to +infinity. Range, it goes down forever, it goes up forever. So also -infinity to +infinity. Zeros, this one also crosses the x-axis. This one crosses at approximately 1.5. So x equals 1.5. See the solution, I'll just use the y-intercept, so 0, -3. Stated non-solution, I'm being very boring. I'm continuing to pick the origin, 0, 0. You can pick any point that's not on the line for a non-solution. You can pick any point that is on the line for a solution. Okay, letter E. This is also not in slope-intercept form. So we want to get it in slope-intercept form to make our graphing a little bit more convenient. So we want to isolate the variable y. We want to get y by itself. So we will add 12x to each side. This gives us 2y equals 12x minus 4. And then we'll divide each term by 2 to get y equals 6x minus 2. Okay, so that's our equation in slope-intercept form. And our slope is +6. Our y-intercept is -2. Okay, so to get the rest of these, we will want to graph the line. So let's go ahead to our y-intercept, -2, and plot our point. Our slope is 6. +6, so make sure you're going, as you go left to right, it's going uphill or increasing. Okay, and then I also went down 6 and left 1 just to have another point. And graph the line. A solution, I'm just going to choose, I'll choose 1, 4. You could always choose the y-intercept, 0, -2. A non-solution, it's so close to the origin, but it does not go through the origin, so I'm still sticking with that, 0, 0. is a non-solution. Domain, it does go left forever, and then it does go right forever. So negative infinity to infinity is our domain. And our range, it goes up forever and it goes down forever. So also negative infinity to infinity. And then zeros, where does it cross the x-axis? It looks like maybe 1/3, so I'll just say 0.3. And this is an approximation, so we'll just use the approximately equal to sign for our 0. Okay, that was example E. Okay, example F. This is not in slope-intercept form, so we do want to put it in slope-intercept form. We want to isolate the variable y. So we will subtract 4x from each side. This gives us negative 3y equals, and remember, we want to write our x value first and then our constant, our negative 12, last. We want to write anytime we have variables and constants, we want to write the variable first and then the constant. So negative 4x minus 12. And then we have y is being multiplied by negative 3, so we just want to divide by negative 3. Whatever we do to one side of the equal sign, we need to do to the other. Negative 3 divided by negative 3 is positive 1. So we have y, 1y equals. A negative divided by negative is a positive. So we have positive 4/3 x. And we are going to leave that as an improper fraction because we actually prefer that when we're dealing with slope because that's our y's over 1. So we're not going to change that to 1 1/3. And then we have negative or minus divided by a negative. So a negative divided by a negative is a positive. 12 divided by 3 is 4. So this is going to be a positive or a plus 4. So our equation of the line is y equals 4/3 x plus 4. Our slope is 4/3. Our y-intercept is 4. Okay, so let's go ahead and graph that line. Our y-intercept is positive 4. So that's our starting point. And then our slope is 4/3, and that's positive, so we want to make sure we're going uphill from left to right. So up 4, right 3. We can go down 4, left 3. And then continue to plot points to the edges of your graph. State a solution and state a non-solution. I'll use my y-intercept, so 0, 4 for a solution. And for the non-solution, I'm just going to choose the origin, 0, 0. My line does not go through the origin. Domain, it goes left forever, it goes right forever. So negative infinity to positive infinity. And we want to use the correct interval notation. Interval notation does matter. And then our range, it goes up forever, it goes down forever. Just want to write those reminder notes to yourself. Negative infinity to positive infinity. Zeros, this goes through the x-axis exactly at negative 3. So x equals negative 3. All right, and so then letter G, we have 96x plus 12y equals 72. This is not in standard form, so we do want to make sure we write it in standard form. There's not a lot of room to work here, so I'm just going to write it a little smaller to the right here. So 96x plus 12y equals 72. We want to get the y by itself, so we'll subtract 96x from each side. This gives us, that cancels out. 12y equals negative 96x plus 72. And then we want to isolate y, so each term needs to be divided by 12. This gives us y equals negative 8x plus 6. Okay, so that's our equation in slope-intercept form. Our y-intercept is positive 6. Our slope is negative 8, so it's a pretty steep slope. So let's go ahead and graph the line. Y-intercept at positive 6. And this one has a negative slope, so it'll be going down as you read the graph from left to right. So I'll go down 8, right 1, down 8, right 1. I can't go down, let's see if I can go up 4 over half. I'm going to go ahead and do that from here, just so I have that additional point, and then I'll plot that, graph that line. Okay, and then solution, I'm just going to use my my y-intercept. So 0, 6. A non-solution, I'm going to use 0, 0. Domain, it goes left forever, it goes right forever, so negative infinity to infinity. Okay, and I know that because I can continue moving left. Okay, even though this line is very steep, it continues going up and left, up and left, up and left. And it goes down and right, down and right, down and right. So I know that eventually I'll get to all of the x values that are negative and all of the x values that are positive. Same thing with the range. It goes up forever, it goes down forever. So our range is from negative infinity to positive infinity. So every number, every y value is eventually on this line at some point. And then where does it cross the x-axis? I would say approximately, I don't know, it looks like 7/8 maybe. So I don't know. Let's just call it 0.8. Approximately 0.8. Okay, and we'll soon learn how to calculate that out algebraically. And then our last example, we have 5x plus y equals negative 8. So we want to put that in slope-intercept form. We'll subtract 5x from each side. This gives us y equals negative 5x plus 8. So our slope is negative 5 and our y-intercept is positive 8. So m equals negative 5, b equals positive 8. So then we'll start off with our y-intercept. So here's our y-axis. Our line goes through the y-axis at positive 8. And our line has a slope of negative 5. So I'll go down 5, right 1. Graph the line. And a solution of this line, let's just choose 0, 8, which is our y-intercept. Non-solution, any point that's not on the line, so I'll choose 0, 0. Domain, it does go left forever, it does go right forever. So negative infinity to infinity. Range is also goes up forever, it goes down forever. So negative infinity to positive infinity. And our 0 is approximately equal to, I don't know, maybe 1 point, it looks like 1.5, so 1.5. Maybe a little to the right, 1.6. Okay. All right, and that is graphing a line in slope-intercept form. Calculating the y-intercept, graphing the y-intercept, and using the slope to plot additional points on the line. And we also talked about characteristics of a line. So what is the slope? What is the y-intercept? Can you state a solution? Can you state a non-solution? Can you tell what the domain is? Can you tell what the range is? And can you approximate a 0? So that is information on identifying characteristics of lines in slope-intercept form.